So we're here, UDIMS. Then next week, troubleshoot. Then we're done. Then you will deliver by December 6th. Something great. So UDIMS, what are UDIMS all about? UDIM. UDIM is just a naming convention. So it just means that we will be utilizing more of the not only the 0 to 1 UV region, but we're going to use more of them. So there's different naming conventions. UDIM happens to be probably the most useful and the one that's used in Mari. Mari is a texturing application that we're not going to be covering in this course, but once you have your production mesh ready and you have your UDIMS set up, you could bring that into something like Mari, which is texturing for 3D, and then texture your creature or character. And it has supports for UDIMS. Also, Substance Painter, that some of you are getting into, has support for UDIMS now, but you can't really paint across the UDIMS. But in Mari, you can. So it is as if, yeah. Essentially, what you want to do when you're texturing is that you want to try to forget about all these technical things, and then things just work. And that's sort of the way this works, is that, yeah, you can have a lot of these patches. So PTEX is another thing. But UDIM, like I said, it's the most useful currently for VFX pipelines. And so, like I said, it's really a naming convention. So you see here, if this were the 0 to 1 UV region that we're looking at in Maya, like this, like we're used to, where normally if you have a simple little asset, all the UVs will be within 0 to 1. But now we're going to use more of these. And you see here, we have 10 this way and 10 going up. So if you have like a hero character for a VFX shot, you could have literally 100 8K patches. And this is common in production. So you have to figure out like what are your needs, like how close are you going to get to the character, what's the resolution you're rendering at, and then you probably want to double a little bit so that you make sure you're absolutely sure it will not look pixelated at all, right? So that's the whole point, just avoiding pixelated effects. So of course, things we've been talking about previously, like texel density. So you're making sure that you have a uniform texel density, and all of that still is very important. So that you have a uniform texture resolution throughout your asset. That's very important, because otherwise you're just wasting a lot of data, right? So, yeah, so you see here, this is as if this were 0 to 1 region, so 1001, 1002, 1003. This is the convention. So when Maya or any other application that supports UDIMS, so Arnold supports UDIMS right now, and we can, in the file node in Maya, we can set it to UDIMS. So now it's gotten pretty simple. And it literally just looks for this number in the file name, and then it will use this UDIM patch, for instance, for that particular texture file. So if it finds UDIMS over here, let's say at this texture patch, it will look for that name in the file node. Yeah. So so I sculpted something while you were sculpting. So this went ahead and did a little bit of tertiary details. So I would have spent more time on this. So the tertiary detail pass is something that you could spend more or less time on. But for this, I used also something called texturing XYZ. Have you heard of this? These are cross-polarized photos, which work really great for tertiary details. So you can literally bring this into ZBrush and use the spotlight feature and actually do some displacement work with these files. So here I have some of the, I think a couple of them on the server. So if you go on the server, you go teaching, tools, resources, textures, and there are some in here. It's the texturing XYZ. Yeah, there's just a couple, and it comes with a lot of these like micro detail, tertiary, all of that. I don't really bother with that, so I just take the displace one. That's sort of the displacement map, and then it's very large. So yeah, so this is 23,000 pixels. So it's very, very large. So what I do is I save like a version of that. So whichever you find useful when you're working in ZBrush, but this is probably a little large. So I'd say what, like a 16,000 pixel wide or something like that. Just because this is ridiculously large. And then it will become quite okay to work with in ZBrush. And then, so I'm not going to really cover too much of that now, but it's just because it's obviously very, very time consuming. It is. Let's not kid ourselves. Like, you know, if you really want to go in there and do a tertiary pass, you're going to spend time. And so, and there are also some really good videos on like the Summit videos. If you want to look into some of those. Did anyone watch some this year that did tertiary detailing? Were some they were using texturing XYZ, or is it? It's quite common now, and it's gotten very good. So, or you know, or you could literally go in there and do everything by hand, or utilize alphas also. So I'm not going to spend too much time going over that, but if you you just have to um, do some R&D on tertiary detailing, that would be. But I would definitely do that once you have retopologized the mesh. So you have a Dynamesh sculpt, right? So you've probably taken it to like a secondary detail stage. So you have some details in the sculpt, in your Dynamesh sculpt, and then you would retopologize it before you do the tertiary details. So this is just quickly retopologized using the C remesher. So this is far from perfect, and you know, but it's okay for a presentation render. But if you really want to have an animation-friendly hero asset, chances are you would have to combine the ZBrush C remesher with some manual retopo in Maya, right? So just to make that perfect topology. But I would do that before you do the tertiary details. And then you would just add normal subdivision levels, right? So this one currently has, it's around 11 million, or yeah, just under 12 million. Because it's kind of, it's not a lot, but it's enough. Because if we go to the lowest level, you can see the way this was retopologized, it actually has more, I can access the frame settings, but you can see it actually has more resolution in the face than it has in the body, a little bit more. So there's a little bit more, there's a little higher polygon density in the face. So this is something that you can do with the C remesher using polypaint. So in the C remesher, I don't know if you tried that, but you can actually, where is it? There it is. So use polypaint. If I hold control there, it will give us a little hint. So you can do, which color is it? Red, I guess? Yeah, pure red specifies a higher polygon density. So if you like experiment with this, if you paint the face areas red, it will attract more polys, and you'll save yourself some time if you do it this way, rather than retopoing everything this way in Maya. It would take a long time. So I think it's a good approach. If you can get it like 90% there using the C remesher, and then maybe taking it to Maya and doing some manual retopo with the quad draw tool or something. Just make that object live, and off you go. And then you'd be working with the tertiary details on that final level. So as far as the UVs, then let me. Yeah, so this I have currently UV mapped with UDIMS. So let me just export this object on the lowest subdivision level. This would be, yeah, I'm just gonna call it creature with UDIMS. Okay, so an OBJ. I'm gonna have a look at it over here. Well, okay, where am I? So this does not have 100 UVs, no UDIMS. It has 1, 2, 3, 4, 5. Let's see if we have. Let me just make a Maya project for this. So. Yeah, so I just literally took this into Hedis and started cutting it open. And this topology was not great. Like you can see there's a lot of spirals. It's actually pretty horrible for animation. So this would not be production mesh in the technical sense if you want to bring it into an animation pipeline, probably. I mean, it would work, but it's just not nice. So the simple thing you'd often see with C remeshers that it gives you spirals, which is something we don't want. We do want continuous edge loops like around here. So if I double click this, you'll see it's just like, where are you going? So you're going here. So this is crazy. So I'd rather we'd have this continuous edge loop. It would just be a circular edge loop. That's pretty simple to achieve. You just have to go over with the C remesher guide curves, right, and like try more versions. So I didn't really bother doing that for this. But it's just everything feels a little bit more rewarding. Like if you took the time and you have good topology, everything will just kind of work a little bit nicer and easier. So when you're cutting this, it would just be a simple job because it has a continuous edge loop there and so forth. But really just cutting everything open, as you see, and probably I didn't have to put a seam right there in the front of his face. If you can avoid it, you would avoid placing a seam right there. Technically, you get away with it because yeah, because we don't want to see the seams anyways. But just try not to put seams like smack in the middle of the face, probably. And then you just cut it open and spread things apart. One other thing that I did is that I actually, when I then spread these into UDIM patches, I don't really, this is quite random. It's like, I'm just placing these. And I could have had more depending on the final resolution that I'm going for. So let's say you're working with 8K maps or 4K maps. It's up to you. It also depends on your system, like how fast of a system you're working on. So sometimes it's preferable maybe to work in 4K maps for your case. Uh, so all these things, and then you would have to consider, like I said, the final resolution. So if we go and add, let's just add a Lambert, and yeah, didn't I put that in there? Yeah, I know there's UV patterns you can enable like in Maya and so forth. I still prefer having this texture file because I'm just sure that it's not going to do weird things with the scaling of it and things like that, which can happen sometimes if you use these automated checker patterns that Maya also can generate. So I prefer having this manual UV pattern in there. And then maybe I can go and maybe I would repeat the UVs sometimes. So you can see they're very uniform. This is what you want to see. So like it's quite uniform patches, very minimal texture distortion. Of course, you're going to see a lot of seams because there are a lot of seams everywhere. But this is just check for distortion, and you're checking for uniform textile density. You can notice that actually the face, the checkers appear a little bit smaller. So I did that on purpose. So I actually scaled up this UDIM, the first UDIM patch a little bit. So I just grabbed these UVs because they are the face. I'm just allowing them a little bit more texture resolution. Just scaling them up. Of course, the checkers are going to become smaller. So that's how you can really tell that this has more resolution, which is also quite useful. So in general, yes, you want uniform textile density, but you can also be creative with it, and especially for the face, maybe you'll allow like a little bit more. It's okay because all the data that you'll be exporting finally will be based on 3D paint or in ZBrush like 3D data. So, but still, we do have like human readable UVs. You know, we can sort of go in here. These are far from perfect, but you can go in here and sort of tell, you know, and if you had to open this in a 2D application and do something to it, you could. It's not like you have patches everywhere. It's kind of, you can figure out what this is. So is that pretty clear? That's, I mean, straightforward. And then it's the same thing. I mean, it's just very important that you don't. This becomes very important right now that we cannot have any overlapping UVs at all. So especially for baking the displacement maps and making them work, we cannot have that. So you'd have to really go in here and make sure none of these UVs are overlapping ever so slightly. It will be a problem. And also, of course, that they're inside their borders, so that goes for each patch, of course. Make sure that none of these patches are outside. All right. Yes. And so I would do this, all of this, before, well, you definitely do the retopologizing before the UVs. Why not just do the UVs also once you have the retopologized one, just do the UVs before you do the tertiary stage in ZBrush. If you didn't, you could always just import, you know, this low mesh back into ZBrush and then reproject onto that. Right? So I would subdivide up and reproject down. That would take a while, and it did take me a while because I did not do that first, so I had to reproject all the details back down onto the 11 million poly a mesh, and it takes a while, but you can do it. You do not want to disturb ZBrush at all. Like when it's doing that calculation, it could probably take, I don't know, 10, 15 minutes or something like that, depending on your resolution or your poly count. You don't actually want to do anything else on that computer. ZBrush is a little grumpy. So if you open up a browser or something, even and just check your email, I wouldn't do that. So just leave ZBrush alone. Otherwise, it might fail. So, so here I have, of course, then the reprojected mesh with UDIMS. And it's at around 12 million polys. So if you really wanted to go higher than this and you had a crazy hero shot and you were to be rendering that at 4K or something ridiculous, yes, you might want to consider going in there, like doing some HD geometry on the face or something, like for really high definition of the pores. But for the most part, and especially I think for a lot of your potential projects here, you can really get away with this level of detail. It's just like you're being a bit, uh, I think that little part where you have a little bit more resolution in the face, it seems trivial, but it actually it's a huge deal because when you subdivide to 12 million, now suddenly we have a lot more polys in the face, incidentally, than the rest of the body. So it's really, it becomes quite important. Anyways, um, so the export here is actually pretty simple. We just use the multi-map exporter as before. Wherever that went, there it is. So yeah, so we have displacement map. So I'm just going to be doing a 32-bit EXR displacement map. There's also something called vector displacement, which is nice. I'm not going to do that now, but it's actually then enabling you to do, if you can imagine, like the displacement map can only either displace out or in, right? But the vector displacement can actually create more kind of like, if you can imagine, like a mushroom shape. So like there's a curvature to the displacement. So we're not going to get into that, but it's pretty interesting. Yeah, essentially, you can displace anything then with vector displacement. Displacement maps will work for the most part, especially for something like this. This is, yeah, we don't have any. There's not like a crazy difference between the base mesh and the final tertiary details. But you can go pretty crazy with it. This is still, like I said, you know, these details are they're not very large at all. But you could add quite large displacements, and they should work fine. So, are there any questions for that? That's sort of the steps we would need to go through. I mean, I could just grab the Dynamesh sculpt and do all the stages, so that you see me do it. So I could grab it, quickly retopologize it, do all the UDIMS, bring it back, reproject. Maybe we'll do that, and if some of you are interested, I can do that at the end, so that you'll just see all the steps. Maybe that's helpful. And right now I'm just telling you all the steps, but I could do it. It would take a little while, but it's just like, if some of you are interested, I think it would be, sometimes it's nice just to see it, you know. But the thing is, this will vary a lot, probably depending on your individual projects. You might encounter some issues here and there. You know, it's like. But anyways, let's just try to get this out of ZBrush, and we'll try to set up a render, and we'll do all of that. And then at the end, I can do all the steps leading up to this, if some of you want to see it. So just enable displacement, and we'll do, here you can do 4K, it's going to flip it vertically on export, which is what we want. So displacement map. The first slider here tells ZBrush which level to optimize the displacement map for. It doesn't mean where it's sampling from. So if you just want all the details, in other words, and you're applying it to a mesh that looks like subdivision level 1, which this does, then this should be set to 1. So why would you ever want to change that? The only reason to change that is if you only want to capture the finer details. So if you want to have like a bump map that could go in addition to the displacement map, you could do that. So well, used to be very common to do. So you would the tertiary details would actually be a bump map on top of a displacement map. Arnold is very, very powerful. So you can just throw the whole displacement map in there, and we have a little feature called auto bump. So it'll actually do that process automatically. So it does that when it's rendering. It actually takes the highest level of detail in the displacement map, and technically it actually does a bump map for it. So it's very clever, and we don't have to think about it. So anyways, adaptive means, like it says, it will be better, but take longer. It's not going to be so much better. It's just going to take a lot longer. So for something like this, no, don't do that. You can do it and then go home and come back like 24 hours later. If you don't want to, it's not gonna, don't do that. It doesn't matter for this, really. And then, so smooth UVs, if you, in most cases, probably want to do that. If you had smooth UVs, mid-range. For 32-bit, we can actually turn that mid-range to 0. And we're going to do EXRs. So EXR is just a 32-bit image format. Have you tried it? Yes. Yeah, perfect. If you haven't tried it, it's just a 32-bit image format. It's an image format with a lot of data. I think it's ILM's format. They made it a few years ago. A lot of years ago. Yeah, that's it, right? I think so. All these things, usually there's some issues. Usually. Something happens, something looks weird. Oh no, I forgot something. Or whatever. There's always something, some crap that happens when you render and something's off. So don't be afraid of that. You know, we're okay. Anyways, smooth UVs. Great. I think this is good. So then we're going to go to file names. So the file names out of ZBrush is out of this multi-map exporter. I can never figure it out. I'm trying to set it, name it this way, and it never really names it correctly. So I always have to, I end up going and renaming afterwards anyways. But there's a big little, the big thing we have to do is actually change the ID format. So this is a different format. We want this to be UDIM. So just click there until it says UDIM. There we go. And one little trick you can do is to go there and actually add a little, you add a dot there after the name. That will add a dot in between the naming, whichever horrible name it will give it, and it will add a dot before the UDIM number, which is required for Arnold to read it. Okay, so that's good. So just add a dot there, and then UDIM, and then okay. So that should work. And probably won't, but let's try. And then you go displacement, create all maps, all this. Yes. Questions? So we're going to try this. We're going to hit create all maps, and then we're going to take a break. So let's hit create all maps, and then we'll come back in 15 minutes. It's only going to take 2 minutes, but yeah, let's take 10 minutes. Let's get some coffee or something. Yep. Ready? Oh. Anticlimax there. Let me just throw this in the data, creature UDIMS. So this is what I'm talking about. You can try to name it, and you can try to be nice, but it won't name it correctly anyways. Yep. There it goes. Let's take a break. Oh no, I didn't stop the recording. But I have to keep the recording. I don't want to interfere with it, so let's see what happens. Take 10 minutes anyways. All right. Yeah, so one of the settings here you see we did not activate is called 3 channels. That the only thing that would have done is place the same data into all of the 3 channels. So currently it's just to save space because this is a pretty large file. So it just uses one of the channels, and incidentally it's the red channel. So when we open up, so here are the EXRs. When we open this in Photoshop, you'll see that it's red. It's just because the information is in the red channel. It's just random. It doesn't matter. So here, this is the grayscale information that happens to be stored in the red channel. So that's why it's red. So there we could go on exposure. So we can't really see anything here because we have a limited dynamic range on this projector. There's a lot more data in the file that we can actually see on a normal monitor even. So here we can use the exposure and we can see that there's actually data there. So it worked. So this is the first UDIM. All right, so let's try to set this up. So for this, no, I don't want you there. Oh, one thing though, which I've neglected to pay attention to at all in this, is the scale. The scale is actually very, very important. Like to have accurate scale when you're rendering will cause like more physically accurate fall off on the lights and everything. It needs to be to scale. So currently, I have just neglected that altogether. So, but obviously, if you, okay, so when you start out with a Dynamesh sculpt, probably you don't care about the scale, you're just like sculpting, and then at some point you will be exporting or you will be retopologizing it, right? So then what I would do is actually, yeah, so once you have the retopologized mesh, right, you export that low-res mesh to Maya, and then you can make, like a measurement cube or whatever. It's like, okay, this needs to be actually 180 centimeters tall or whatever, right? And then you'd scale up the retopologized mesh, and it will give you a very exact measurement of scale, of the scale change. So then what I do is I copy these numbers, and then I bring in the high poly version, let's say whatever, how much your original Dynamesh sculpt was, maybe around 4 million or something, like not including the tertiary details necessarily, which would be higher, but 2 to 4 million, whatever your final Dynamesh sculpt was, and then you bring that mesh into Maya and you scale it up, just pasting in the exact same numbers into the scale. And then you bring both of them back into ZBrush. Now you have a correct scale, and then you can reproject the Dynamesh back onto the retopologized version, which now has the correct scale. Right? Makes sense? The new ZBrush is better with scale, though, so maybe you can set it up correctly initially. Whoa, I don't want you zero scale. Yeah. But this is how I used to do it, but I just forgot. So anyways, it will still work, obviously. It's just that this it's just a random scale. Okay, so did that make sense? Some people are nodding. Yeah. So let's try to find the standard surface. There we go. So I'm just a normal. For this course, if you do a beautiful clay render, that's perfect. So you don't have to obviously texture anything. Just have tertiary details baked down in a beautiful clay render. That would be nice. If you want. Okay, so now it has that one. Okay. So I'm going to graph it down here. I want you to go away. If I click here, it will graph input and output connections. So we see that the material, which is the AI standard, is connected to this shading group. Right? So to see that, you'd have to click here, show input and output connections. You can see that this is the standard surface is actually the surface shader of this shading group. Now we're going to add a displacement shader. So we can do that here. So you see displacement material. I'm going to click right here. And we're going to create a file node. And see what it does. It adds this displacement node. So this is kind of like a bump node. It's just a different node. So displacement node. And you can see a normal file node going into the displacement value right there. Okay, so we're going to click the file node. And we're going to turn off filtering. Turn that down. Image name. And here, okay, let me move those over. So I just put them in data. So here, if I wanted to, you can go in and rename these. And if you have like a bulk renaming application, adding that dot before that would enable you, like we did in ZBrush, we added the dot after the DM. So here, if you had a bulk renaming thing, let's say you had 100 of these, you don't want to be doing this manually, this would be very easy to rename all of those 100 files automatically. But for your cases, probably you'd have a few, like 10 or whatever, 5 to 10, and so you can just rename. So this would be displacement 101. It's very important to have that dot. There we go. And then I'm going to move these over to source images. And here they are. So just select the first one. And here, this is the handy new feature. So we can set this to actually be UDIMS style tiling mode. So you see it automatically. So yeah, I found 5 tiles. So it used to be that last year still, but I think it's better now. Arnold used to be very finicky about this. It wouldn't like the UDIM would need to be lowercase and so forth. But now I think this works. Let's see. Like I said, usually there's some weird things will happen. You have to keep trying. And yeah, but this is it. So you can see that it replaced the number with brackets and UDIM. This is the token that needs to be there. And then we just replace those letters, obviously, with whichever UDIM number it can find, and it will correspond to the UDIM patch and the UVs. So, okay, and color space needs to be set to raw. This is a 32-bit image. And auto-generate TX textures can be on. So Arnold likes, this is Arnold's own thing. So it will actually generate something called TX textures, which it's its own little file that will just make the renders quicker, more efficient. So just leave that on. It can auto-generate TX textures, and it will use those. It's okay. And so this is like the first thing we need to do. So we added the displacement shader to the shading group. We added the UDIMS. Good. The second thing, the way Arnold handles the displacement settings is actually per object. So I can click the object and then go to the attribute editor. And then we go, you need to find the Arnold tab on the shape node. And there's a lot of things here, but under subdivision, so these are the two settings. So subdivision and displacement attributes, right? The only thing we're going to do here is click auto bump. This is what I was talking about earlier. It's going to read the finer details in the displacement map And it's going to actually technically do a bump map on top of the displacement map. So it's more efficient use of the data. So the auto bump, no, it's okay. And here, this is what we're used to, right? This is subdividing. It's literally the same thing as you would like subdivide in ZBrush. So we're going to set this to Catmull Clark. These are the iterations. And how many iterations do we need? We actually have a very precise number for that because this is, oh, this is another important thing. So if you're projecting down to the mesh, okay, so you retopologize it, you make UVs for it, you bring it back to ZBrush, and you project back down onto the new retopologized mesh, right? That will actually change somewhat the vertex coordinates a little bit in the low res as well. Make sense? It will push those vertices a little bit. That's why it's very important that you actually use this new mesh as the base mesh for your displacement. Not the one you exported earlier to do the retopologizing and the UVs, but the new one after you did this projection. That you need to export that one, this one. This is important because otherwise your displacement will also kind of look strange, possibly, because the vertices might be off a little bit. But anyway, so we have a very precise number for this under geometry, because the highest level here is 6. So we have 6 subdivision levels. That's the number. Like for a test render, maybe we'll just set that at 4 just to see what's happening. Here, this will pin the UV corners. I'm going to pin the borders so it will, yeah, I think more likely do a better job at keeping those UV shells because I just want those UV shells to be, yeah, you get the idea. The UV, it will pin the borders of the UVs. Anyway, so if you see something's messing up in here, maybe you want to consider changing the UV smoothing options. And yeah, let's try it. That's the only thing. And like I said, probably something's going to happen. We're gonna be, let's see. And we'll add some Arnold lights. I'm going to add a very, very simple aerial light just to have just some harsh contrast here so we can really see those tertiary details. And if we go to camera, we can activate the resolution gate. So this allows you to actually see the frame that's being rendered. For fun, let's just make a little backdrop of sorts. So if I get rid of those. Whoops. Yep. We'll add in. It's just nice to have something there so the light can actually have a chance to influence the background a little bit. What's going on? Can't really. Okay. And yeah, smooth it. And reverse. Whatever. Okay, just so there's something there. And then what's up with this? Hello. Here we go. I think it's set to snap. Anyways, and then whatever you're using Arnold, we do want to use actual Arnold materials. I'm just gonna I'll make another one just for that. And I think we'll do a little, yeah, just like a little render for a test render, not too crazy. So initially this has a lot of specularity though, so I think we'll turn down the weight. Let's see. Yeah, we'll just turn down the weight of the specularity on, or the color on the backdrop. So when you're doing renders and test renders, it might be a good idea to make a camera. So you make a render cam. As if maybe this will be the one I'm rendering from. So render cam. Now if I go to the other perspective camera, I can turn off the resolution gate on that. This is just my normal perspective camera, and here I can see the render cam. And it's just a little bit easier. So whenever you're look deving and you have to do more renders, it's just nice to have that defined camera. And then whenever you want to look at it, just go in here. So here you can change between different cameras. Okay, let's try. Let's double check. Catmull Clark, 4 iterations, auto, I guess that's fine. Raster, okay. Pin borders, sounds good. Auto bump, yes. And we have a light source, everything should be good. We're using Arnold. Okay, I guess we should save the scene. And now I can't move anything, so that's interesting. Oh, it's starting the render. If you hit escape frantically, it will stop the render. And then it actually works. We're going to save the scene. Yeah, just keep hitting it. Okay, ready? But we're actually going to render using the render cam. This will be the moment of truth. There's probably some errors. Maybe not. We'll see. So this could turn out to just be like a huge blob. Then you know it's not displacing properly. Okay, it's not a blob. That's good. Yeah, it seems to be working. Yep. So here we're off to lighting and rendering and all of that, which is not really my field. But you should pick Paul's brain when he's here. So this obviously goes hand in hand with compositing, look deving, rendering. Yeah, but here you go. So here, I mean, it's working technically. What becomes important now is following linear workflow, you know, setting up proper renders, all of this, and it's you're very lucky that Paul's here, because I would get into the habit very early of just setting this up in Nuke, like doing some passes while you're looked at rendering. You know, why not? So yeah, yes. So to really get good high fidelity, like the reason we've been fiddling around with all these settings and have the UDIMS is that so we can finally get more fidelity, we can get more detail. So of course you do need to render at pretty large resolutions to really see that. So when you're doing these test renders, you can't not really see. You do have to, we do need more resolution. So I think I'm just gonna do like let me just do a 4K square, whatever, and I'll increase the samples of the diffuse, and we'll also increase the samples on this light. So sampling is just like yeah, the quality will increase quite a bit. This will take a while, but we can save it, and we can take another break. This time there will be time for coffee, for sure. But let's just kick this off. We'll take a break, we'll have coffee, and we'll come back in 15 minutes, and that'll be good. And then if you have any other questions, I'll be happy to answer them then. But we need coffee, and I'll start the render. Do the render cam. Yeah. So if you want, if some of you are interested, we could try this whole process with one of your models. It would be quickly done, just like boom, boom, boom. Should we try? No? Not interested. Hmm? Break? Let's take a break. Yeah, I'm always up for breaks. Yeah? Want to try it? Yes? Who has a model? Someone? No? Hmm. Anyways, guess not then. Huh? Yeah, a little bit. It's just his natural expression. Don't judge. It's a bit too specular, obviously. So this would be the look tab period. You'd go in and, you wouldn't add all those UDIMS to do look tab on the material. You would do that on a very simple little render without any UDIMS just to dial that material perfectly. So that's more a different topic of rendering and look tabbing. In this course, like I said, a beautiful clay render, probably a little less specular than this, which would just show all these. That's very specular, yeah. Let's try to. Anyways, so the thing is, this obviously takes time. I don't want to bore you to death. So, but that would look a little nicer, obviously, if I had remembered to import all these other little meshes for the eyes and the teeth and the tongue. And probably would have left the eyeballs a little more specular than the skin. Anyways, but it works. So, yes, unless you really want to see this whole process, would anyone be interested? You're interested. We have a taker. So we'll do it. Yeah. Okay. So it would literally be like just doing everything. If you have a Dynamesh sculpt, what do you do? Well, then you have to retopologize it. You have to make UVs. You have to do all of it. So if you want, I will do it now, and that'll be good. We need a break. Just kidding. We will not. We will keep going. I had a question. Why don't I use the Arnold render view? There's no reason for this. It's just because I'm not terribly used to it, but it is better. It is a better render, and you have more access to, and it's also a progressive render. So if you start this, it will progressively update the render, which is probably not something that's terribly useful for multi-UDIM renders, but this is more for look tab, like when we're say tweaking a material to make it look like skin or something. And anyways, like I said, I don't know much about it. But yeah, yep, yes, nice. So, yeah, okay. Any questions about this though, right now? Let me stop the recording. I'll start the recording again, and then I'll do it. If some of you are terribly bored and you have other things to do and you feel quite confident, you don't have to stay around.